Hey everybody, so here is our second video. So different classes kind of got through different points and I did have some people gone. So I'm actually going to be starting on page 14 of the notes. I'm going to probably be reviewing some problems with you, and you are more than welcome to fast forward the problems that we already went through, so just kind of pay attention to where we are. The other thing you're going to want to have in front of you is this little cheat sheet that we made on the back of our factor page. If you weren't in class, there's going to be a picture of this in the week 10 folder, and you're looking for your green factor page. That's what we wrote it on the back of. You can put it on any piece of paper, but it's kind of like a little cheat sheet, a guide to solving. So I'm going to be using this as I go through the problems. All right. And again, if you don't want to watch these first couple problems because different classes got to different points, fast forward and get to the problem that you need to get to. All right, so just a reminder of what this cheat sheet says, solving polynomials. If you have more than one type of x, so that would be like x squared and an x. So you have x's with different degrees attached to them, x to the second, x to the first. This has more than one type of x because it has x's to different degrees. But in this problem, I only have one x, all right? I don't see another x. This is to the first degree. So we solve them differently. So if there's more than one type of x, our goal is to factor. First step of all factoring is GCF. After that, if you can, you're going to see if there are two terms. That's that whole difference of squares. Or you're going to do three terms and make your x. And then in a later chapter, we'll talk about what do you do if there are four terms. Now, if you can't factor in Algebra 1, you learned that little song, the quadratic formula, x equals opposite b, da, 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 da. I'm not going to sing it. And it goes x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And you get the a, b, and c when you see it in standard form. And a is the number or the coefficient with x squared, b is the coefficient with x, and c is the value that's just by itself. It's called a constant. All right? If there is just one type of x, then what you're going to do is you're going to isolate x, which means you work backwards in the order of operations. And everything has an opposite. So what we talked about is that exponents have a radical as an opposite. All right? So again, you can fast forward through some of these problems if you're still listening. But the first thing I'm going to check is this one. So I see more than one type of x, which means I am going to try to factor. I'm going to do a GCF, and then since there are three terms, I'll go for the x. The other thing, kind of summing up as what's up here, is I should expect to know how many answers I have. And this box up here says the fundamental theorem of algebra that says whatever your highest degree is how many answers you should have. So I will be getting two answers from this, and the first thing I'm going to look for is there a factor, a GCF I can factor out of all three, and there's not. So we make our x, and I'm going to multiply those and get 24x squared, and then I'm going to circle this one, and I'll get negative 11x. So now I want factors of 24 that get me to 11, and I'm just going to use my factor page, and the factors that will get me to negative 11 would be with this 3 and 8. So I'm going to have 3 and 8, and they will both become negative because the idea is when I multiply these two, I get the number on top, and when I add them, I get what's on the bottom. And from there, I can go straight to my factors, or I'm looking for the neighbors who met that got me this. So the first thing I want to see is who met who to give me 2x squared. So that's going to be a 2x and an x. And then I'm going to let these side numbers guide the rest. So the first thing I want to see, could 2x meet somebody to give me negative 3x? And it can. So that means 2x has to meet somebody to give me negative 8x, and that would be a negative 4. So then, since I found this one, I'll ask myself, well, can x meet somebody to get negative 3x? And it can. It can meet negative 3. And so we have factored. So now what we have to do is solve for x. What I want to know is what number, if I put it in for x and do all this math, gets me to 0. Well, that's much easier to solve when it's in factored form, because there's this thing up here called the zero product property. And it basically says if you can get it down to the factors, then if you can get this factor to equal 0, find a number for x, put it in there, then even if you get a number here, it won't matter because 0 times any number will give me 0. Or maybe I could figure out what makes this factor 0, what value for x if I put it in there gives me 0. And then if I take 0 times whatever number I would get out of this, then 0 times that number is still 0. So essentially what you have to do is once you get there is you take each factor that is solvable and you set them equal to 0 and you solve for x. So here it's pretty simple. To solve for x, I just add the 4, and so there's one of my two answers. It's 4. In this one, I'm going to add the 3 over, and then I'm going to divide by 2, and I get 3 halves. Okay? So if you're watching this for the first time, one thing I didn't explain in class is not only are we solving, but we're actually seeing where our graph intercepts the graph, where it intercepts the x-axis. Because if I put x in here, I'm solving for x, x is 4, and if I do the math, I get 0 as my answer. And that means I actually have found an x-intercept, 4, 0. And if I have x be 3 halves, and I do the math, I get my y to be 0. And you can see that if you actually take a moment and put this in your graph, which I'm going to do real quick, which I should have had this ready to go. So I'm just typing in to my graphing calculator 2x squared minus 11x plus 12. And what I'm finding, once it gets there, well, it's being a little slow, so let's try this again. And I'll have to figure this out once it loads. I'm not sure what's going on. Anyway, the little wheel's spinning. It's a little tired, I guess. Anyway, so 2x squared. I think I figured out my mistake. Sorry to keep you waiting here. Okay, and so what I can see is that it's hitting my graph at 4, so there's 4, 0, and there's that 3 halves, which is 1 1/2. So again, when we're solving, we're actually seeing where our graph hits the x-axis. All right, so on this one, I see more than one type of x, so I'm going to go about factoring. Again, the first step I do is always look for a GCF. I can see that GCF. I'm going to take an x out, and then I get x minus 8. After that, I want to see, since there are two terms, is this a difference of squares? I do see the difference in the subtraction, but in a difference of squares, your two terms have nice square roots, and 8 doesn't have a nice square root, and there is no square root of x. So I'm actually done factoring. And now what I'm going to do to solve for 0, what number, if I put it in here and do all the math, I'll set each factor, each neighbor equal to 0, and I solve. And so again, x equals 0, I don't have to solve, that's already done. And in this one, to get x by itself, I just add 8, so I get 8 as my answer. And again, just to show you, not only have we solved for x, but we've also found the x-intercept. So here's this one graphed. And you're going to see that when it hits the x-axis, that's 0. So if x is 0, y is 0, and this is 8. If x is 0, y is 8. So if x is 0, if you put 8 in here and you do your math, your y value is 0. I hope that makes sense. All right, let's go to the one below it. Again, I see more than one type of x with different degrees. So the first thing I'm going to do, again, is a GCF. I notice I can factor out an x from both of them. And then, again, I'm left with two terms, so I do want to see if this is a difference of squares. I do see the difference, and I see that this has a nice square root, and this has a nice square root. So, joining my GCF of x, I'll get my new factors, and it's so simple. It's 2x minus 5, 2x plus 5, and now I'll set each factor, one that needs solving, equal to 0, and I'll solve. And again, what's really nice about this is that this one is already solved. Whoops, you couldn't see that. So this one's already solved, and this one I'll add 5, and then I'll divide by 2, and I get 5 halves. And in this one, I'll subtract 5, divide by 2, and I get negative 5 halves. So if you graphed this one, I'm just going to show you what it looks like. It takes a moment. I should see my shape hitting the x-axis 3 times because I have 3 solutions. So there's the negative 2.5, there's the 0, and that's x is 2.5. And again, these are the x-intercepts. When you have these values, their y is 0. So if I put 0 in here and do the math for x, my y is 0. If I put 5/2 in here and do the math for x, my y is 0. So in the last one, we actually have one type of x with 1 degree. So what I like to do is we're going to isolate x, and we're going to work backwards in our order of operations. And I would always suggest you write this down. So the first thing I'm going to move to isolate x is the adding and subtracting. And it'll be the +2 because the -3 is in the parentheses. So I'm going to -2, which leaves me with this. And when I subtract 2 from here, I get -72. So that step's done. Then I'm going to move my multiplying and dividing. This -2 is multiplying to these parentheses, so I'm going to divide. And then I get x minus 3 squared equals 36. And now to undo my exponent, I will use a radical. And since this is squared, I am going to square root. And when I take the square root cancels out the squared. And when I take the square root of 36, I get 6. And now if I add 3, I have an answer of 9. But this says I should have 2 answers. So I'm going to put a simpler problem. And again, I did this in class. And if I were solving for x here, you know, I would want to know what number times itself gives me 36. And so that's 6, because 6 times 6 is 36. But it's actually also -6, because -6 times -6 is also 36. So when I do this square root step right here, I will get 2 answers. I'll get a positive and a negative answer. It's not the answer, but it's on my way to the final answer. So when I take the square root, not only do I get 6, but I also get -6. And then I have 2 problems to solve for, one with 6 and one with -6, kind of like that absolute value. So here I'll add 6 and I get 9. And here when I add 6, I don't get -9, I get -3. So then I get my 2 answers. And again, if I were to graph this, this is where my graph would hit the x-axis. Okay? All right. So I'm guessing this is where we left off with most of the classes. So again, the first thing I'm going to do is GCF. I notice I can factor a 3 out, and that's it. So I'm going to take that 3 out. And I'm left with x squared minus x minus 6. And again, why am I factoring? Because there's more than one type of x. I have x with different degrees. And then I'm going to keep factoring here. And since it's 3 terms, according to my cheat sheet, I should make my x. So I'm going to make that x. So factors of -6. That get me, that's like a 1 and -1. And I showed you how to run your factor program. I'm just going to use the paper. And which of these will get me to 1? That will be the 2 and the 3. So I fill it in with 2x and 3x, and the 3 will have to be negative. So when I multiply these, I get -6x squared, and when I add these, I get -1x. So joining my GCF of 3 will come my factors, or the neighbors who met, to give me this. So again, who met who to get x squared, that's x and x. And now I want to use these and ask myself, can x meet somebody to give 2x? It sure can. It can be 2. And can x meet somebody to get -3x? And it can. It's -3. And now I'm ready to solve. Again, I'm going to have 2 answers, and I'm going to solve for the factors that need solving. So this factor is 3. It doesn't need solving. Done. But this factor needs solving. So I'm going to set this one equal to 0. And then this one needs solving as well. I'll set this equal to 0. And I'm going to add 3. And I'm going to subtract 2. And there are my 2 answers. On this one, this time I see one type of x, right? Not x's with different degrees. So I'm going to isolate x. That's where I like to draw the wall. I'll remind you of your PEMDAS backwards. And the first thing I'm going to move is the addition subtraction. That's the 31. So I'm going to add 31. And again, I got my calculator because it's 4th period on Friday and I'm a little tired. So if I take 225 and add 31, I get 256. And now I'll move any multiplication division, so that's 4 is being multiplied, so I'm going to divide. And 256 divided by 4 gives me 64. And now to undo the exponent, I'm going to square root. And remember, it's in this step that you get two answers. So to undo the square, I square root. And what squared can give me 64? Well, 8 times 8, but also negative 8. So there are my two answers. All right? On this one, I'm 3 terms. So I'm going to first look for, an x with more than one type of x. I'm going to look for a GCF. I don't see one, so I'm going to make my x. And I'm going to look for factors of negative 8 that get me to negative 4. So this time when I look at my factors of 8, neither of these actually get me to 4. So this is where you're a little sad because you love factoring so much, and so you're going to cheer yourself up, and you're going to do that by singing your song of x equals opposite b plus or minus square root, okay? So first we're going to establish what a, b, and c are. So since this is not factorable, a is the coefficient in front of x squared, so a is 1. B is the coefficient in front of x, and so we're going to look at that as a negative 4 because usually it's plus. And c is the number that is by itself. It's called the constant. And now I'm ready to sing my song. So to solve for x equals, I take the opposite of b, and then I plus or minus square root. And the reason why there's a plus or minus is because of that square root. When you square root, you get a positive and a negative version of the answer. And then I'll take b and square it. So this is, I just do this in my head, negative 4 squared. I never type it into my calculator because if you don't type it in correctly, you get it wrong. And just know, when you square a number, it's always positive because you'll have a negative times a negative or a positive times a positive. So negative 4 squared is 16 minus 4 times a times c. And again, I'm just using this formula, b squared minus 4ac. And then all of this, not just the radical, but all of this will be over 2 times a. And this is another one I just do in my head. 2 times 1 is 2. So from there, I work inside the radical. So first I do, because this is just a bunch of numbers, I do have to follow the order of operations. So when I have subtraction versus multiplication, I do have to do the multiplication. So 4 times 1 times negative 8. This all becomes negative 32. So now I have 16 take away negative 32. And when I have 16, I take away negative 32. What I end up with is 48. And then all of that is over 2. So let's talk about answers. This is a pretty good answer. But in geometry, you learned about simplifying radicals. So what I want to do is see, in a radical, you need the smallest amount in there. So 48 isn't perfect, but there might be factors of 48 that are. So if I look at this list, do any of these numbers have a perfect square root? So 3 and 16 do, 4 and 12 does, and so it boils down to just between these two. And I got to choose one. So 16 has a perfect square root, it's 4. 4 has a perfect square root of 2. So when I have to choose, I always go with the bigger number. And this is called simplifying the radical. So I'm going to break this down into the square root of 16 and the square root of 3. This is equivalent to this. And then the square root of 16 will become 4. So now another good answer is 4 plus or minus, and instead of radical 48, it's going to be 4 with the radical 3 over 2. So this is an answer. This is a much better answer. But then you can get the best answer. And because this is technically a fraction, you're going to see if you can simplify the fraction. So I make this triangle like this. And I'm going to see, can I simplify it? And it only works with the numbers that are not in the radical. The 3 can't be a part of this. So if I can't make a triangle, I don't try this. And I just look, is there a number that I can divide out of all of those? And I can. It's a 2. So I'm going to divide this by 2, and it becomes 2. Divide this by 2, and it becomes 2 with the radical 3. And divide this by 2, and it's 1, which you actually wouldn't even see. So, as far as the answer goes, this is, like here. This one's about here, and this one's the one we want. That's your goal to go for. All right, let's try this one. And again, I was supposed to have two answers, so let me clarify that I do have two answers. I have 2 plus this, and that's one amount, and I have 2 minus this, and that's my other amount. So in this one, I'm supposed to have 3 answers, but there's only one type of x, so I'm going to isolate that x. Here's my wall. I'm going to add 27. And now, to get rid of the cube, I'm going to cube root. So on your calculator, where is the cubed root? Over here is your math button. You're going to press the math button, and you're going to choose the 4th option. And in there, I can then just type in 27, and my answer is 3. And that is actually the only other answer. It is not -3. Remember, this 3, if you put it back in here, it means 3 is multiplied 3 times. Or if you put it back in here. So 3 times 3 times 3, 3 cubed, that is 27. But if you made them negative, first when I multiply those, I get 9. And then 9 times -3 is -27. So -3 is not a solution. So this is our only real solution. Later on, we will learn about imaginary solutions. So there are actually 2 more answers, but they're imaginary, which means, remember, little kids have imaginary friends. You can't see them right now, but eventually they're going to become something that we see. All right, let's finish these 2, and then we're done with our notes. So in this problem, I see 3 terms, more than one type or more than 1 degree of x. So I'm going to see if there's a GCF. There's not. So now what I'm going to do is try to factor it. And I'm going to see, do I have factors of 40 that get me to -4? So when I look at my factor list and I go for 40, will any of these get me to 4? No, 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 and no. So again, gosh darn it, this isn't factorable. So I'm a little sad, and I'm going to sing myself a song. So in this, A is 8, B is -4, and C is 5. And again, I have this in my formula. Whoops, sorry, right here. I know what A, B, and C are. And now I'm going to sing my song to cheer me up. So x equals opposite B, so I'll put 4 plus or minus a big square root. I'm going to take B and square it. -4 squared in my head is -4 times -4. This number is always positive. Then minus 4 times A times C. And then it's all over 2A. 2 times A, so 2 times 8, which is 16. And again, where I start is inside the radical. So subtraction or multiplication, I'll multiply. I'd like to do 8 times 5 for 40, and then 40 times 4, and I get 160. And then 16 take away 160 gives me -144 over 16. Whoops, sorry, you can't see that. And now what you might want to try to do is, you're like, oh, wait a second, isn't 144 perfect? Maybe you're not thinking that. But if you try to take, hold on, I got to make sure my calculator's in the right setting. Yep. If you try to take the square root of -144, you're going to be getting an error message, and it says non-real answers. So in this problem, this is kind of get you to see what's going to happen soon, is I should have 2 answers, and I do, but they're not real answers. According to my calculator, they are non-real. So as far as real answers, it doesn't exist. And if this happens to us on our test, we're just going to leave it like this for now, and we'll worry about it later. All right, last one. I see more than one type of x, but what I want you to notice is this problem looks different than any other that had an x squared and an x. And so this is a good time to bring up that in order to factor, it's got to be in standard form. So it's got to be the x squared term, the x, and then I have to subtract the 5 over, because standard form needs to be ax squared plus bx plus c, and it has to equal 0. All right, so now I'm going to 3 terms. There's not a GCF. I'm going to try to factor. So factors of -5, they get me to 3. Well, the only factors of 5 are 1 and 5, and that's never going to get me to 3. So again, not factorable. You're a little sad, so now you're going to sing your song. And in this problem, A is 1, B is 3, and C is -5. And so here comes our song. X equals opposite of b, so I'll put negative 3 plus or minus my big square root. I'm going to take b and square it, so 3 times 3 in my head, that's 9, minus 4 times a times c, and then all of this will be divided by 2a, so 2 times a, which is 2. And again, always start in that radical. Get used to the fact that you will multiply first, so 4 times 1, that's 4, times 5, this becomes negative 20. And then when I have 9 and I take away negative 20, that becomes 9 plus 20. So in that radical, I end up with 29. Oops, sorry, you can't see that 2 there. And then I want to see, just like on this other one, well, wait a second. You know, maybe there's something about 29 that's perfect. It itself is not perfect, but maybe there are factors are. So I'm going to look at 29. I'm going to see if I can simplify that radical. And you know what? The only factors of 29 are 29. So this is the best answer you can get for that. And just to show you, you know, when we're solving, I mentioned earlier that we're always seeing where our graph hits the x-axis. And when I have an x-axis, you know, I can't see radicals in that. So what you can do, let me show you how to just type this in. I'm on the main screen, and this will come in handy. You can do negative 3 plus the square root of 29. And now what I have to do is hit enter on my calculator so my calculator knows that that's the numerator. Or I could just make a fraction and then type this in parentheses so my calculator knows that that's the numerator. Anyway, I'm just going to hit enter. There's my numerator. And then when I divide it by 2, here's one of my answers. It's a little bit more than 1. So one of my answers as a decimal is this. And then I could do this again, and this time just hit subtract square root of 29. There's my numerator, and then I'll divide it by 2. And so my other answer is about negative 4-ish. And if I ever want to see if I'm right, again, I can go to my calculator, and these should be the x-intercepts. So I'm just typing this problem in. I'm going to hit graph, and I should see an answer around around 1 and around negative 4. And there's 1, it's a little bit more than 1, and there's negative 4, it's a little bit less than negative 4. So my answers are right. So a great way to check your answers is with the graphing calculator. That's it. Those are your notes. So what would I like for you to practice? And I take it back. Well, I'm sorry, folks. I just realized I didn't flip the page. So I'm actually going to pause and go ahead and tell you the first part of your practice. And then I'm going to show you the other thing, which goes really quickly. So what I would like for you to practice this week is, you know, there are a good amount of problems here. I would like for you to do the odd problems on page 18 and 19. All right, so I'm going to stop the video here. You can go ahead and get started. There will be one more video. It's going to be quick, and it's going to be using your graphing calculator, okay, for the most part.